And after the topic of the image formation, there is a concept of defect of vision. Defect of vision means that in our daily life, many people use glasses to see the object clearly, because sometimes there is a problem in the eyesight of the person that he or she was not able to observe the distant object, or sometimes person was not able to observe the close objects, right? So that is known as defect of visions. This topic is also included in biology because that is related to the eyesight. So basically, if we consider the structure of our eye, so we are not going to discuss the whole structure. If we consider our normal eye, so normal eye contains a convex lens, right? So basically, our normal eye contains a convex lens uh, that is like the natural lens of our eye. So you know the property of the convex lens, right? So our eye also act like a
Right.
convex lens, because we know that in convex lens, image can be formed, a real image can be formed clearly, right? If there is a concave lens, so image will not form, because concave lens will always form a virtual image, right? And this convex
Right.
lens actually helps to focus the light. So we already know about convex lens. So same process we use for the eyesight. So in eye, we are having convex lens that help us to focus the light rays coming from the object, right? But there are two different problems that was encountered by the different persons. Let's suppose if object or the person is not able to view clear a nearer object or the distant object. So the first defect of the vision is the short-sightedness. So the first concept is related to the short-sightedness. And if we talk about the problem that encountered by the person having short-sightedness is, so in short-sightedness, you are able to see near objects clearly, right? See near objects clearly. Basically, the problem is that distant objects are actually blur.
Oh yeah, it makes sense.
Yes. So you are not able to see the distant object because those distant objects are actually blurred. So due to that problem, a person is not able to observe that distant object. और in simple words we can say that जिस तरह से दूर की नजर खराब होती है, जिसको हम कहते हैं simple words में, so that is actually short sightedness, right? Short sightedness means, short means you are able to see near object, right? So
Mhm.
short-sightedness means you are only able to see the near objects clearly, and if you observe the distant object, so that was not clear, that was actually blur. right? So now,
Yes.
what is the problem scientifically? Because we know that eye actually works as a convex lens. So actually, what is the problem in scientific way, right? Because this is the journal term, and we know about this concept. So this is the journal concept. But if we want to talk about with the scientific term, so what is the difference actually? So the problem with the scientific problem is, let's suppose if you consider your eye, right? So in your eye, we are having a convex lens. And if you studied this topic before, so you know there is a point in our eye which is known as retina.
Yes, I've heard of it.
Yes. So basically, retina is the point when light focus on this point, right? So then you are able to see clear object. But the problem in the short-sightedness is, let's suppose if we consider light rays coming from the object. So these are the light ray coming from the object, and they will cross. So you can see they intersect before the retina, right? So this is the problem, because in your eye, we have to focus the light ray, or I should focus the light ray on the retina. So then you are able to see a clear object, but your image is not focused on retina. So that is the problem, right?
Yeah.
So this is the first problem of short-sightedness, when or the image of the object is not going to form on the retina. So how to solve this problem? Because we know that your image is focused short, or you can say that your image will focus very short distance before retina. So you have to move this focus point towards retina. So which lens will help you to focus these image on retina? Convex lens or concave lens?
Convex?
Basically, convex already converge light, right? So basically, your light is
Wait,
already
so,
converged. Yes,
oh, so concave.
yes. So this is focus point. So basically, we have to shift this focus to the retina. And to focus this point to the retina, we have to use a diverging lens first, right? So let's suppose to correct this problem, or to correct this defect, what we need to do, we need to use a concave lens. So if we are using a convex lens before eye, because we use glasses, right? And in glasses, there are two types of lens we use, the convex or the concave lens, right? And sometimes you observe some people wear glasses, and the density or the thickness of the glass is different, right? You observe that there is a small circle at the bottom of the glass, and other glass is normal one, right? So there are two different lenses used in that glass. So when someone wants to read something, so normally we use to read words from book or any other source by the lower our eye level. So then we use different lens over there. And when you are observing the normal objects, So that is at the different level. So normal glass will be made up of different thickness. So the problem that we are talking about is short sightedness, and to overcome that we have to use the concave lens. And when concave lens placed before the eye, so let's suppose again, if we draw the ray diagram, so rays are actually moving from the lens, and they will diverge. Okay, now you can see, if you compare with the first situation, so in your first situation light rays are very close to each other. So when you use the diverging lens, so light rays are automatically diverged from their original path, and when they pass to the convex lens of the eye, so let's suppose if we consider the convex lens again of eye, so the new path for the light ray will be different. So they are actually moving away, so they will focus the light ray on the retina, right?
Yes, it will.
Because in normal situation light rays are coming from a very close distance, so they will focus very quickly. So that's why we use diverging lens, and with the help of that diverging lens light ray will focus on retina, like this. Okay, so this lens will help you to focus your light on retina, right?
Yes.
So this will be your retina of your eye. Okay, clear? Any confusion?
No, sir.
So whenever you find the problem of short sightedness, so we have to use the concave lens. So this is the important thing that is related to the short sightedness. So if they ask about the correction, that how to correct this defect, so you will say that we have to use diverging lens used to diverge light rays, and then they will easily focus on your retina. And by the name diverging lens, we are talking about concave lens. Clear? Any confusion?
No, sir.
Okay. And one more point that is important one. So actually that point explains you. So whenever they ask about the short sightedness, so always remember that in short sightedness case, light rays converge at short distance from lens, right? So due to this problem, we name this defect as short-sightedness because light rays are converged at a short distance from the lens, right? Or lens means we are talking about retina. Okay.
Right.
So image will not form on the retina, so that your distance will be short from the retina. Okay.
All right.
And if we talk about the second defect, so what will be the second defect? Second defect will be a long-sightedness, right?
You can see something from the distance, but not anything near.
Mirror.
That's what I was thinking. Like
Uh,
long-sightedness.
okay, so basically when you are using mirror, so if mirror is placed close to you, right? So then you are able to see a clear picture in mirror, but you are not able
Yeah.
to see the real object clear, right? Because
So like
object
the
is at
mirror is like
distance.
a virtual, because
Yes.
the object would be like a virtual.
Hmm.
Okay.
Yes, because object was not there, but you may use mirror to see that object for the time being, but you not always carry mirror everywhere to see the object. But still, if mirror is close to you, so then they will help you to see the object for the time being. And the next concept is related to long sightedness. So in long sightedness is completely opposite to the first point. In first point we discussed that distant objects are blurred. Now this time distant objects are clear, but
But like the near objects are blurred.
yes.
Okay.
So completely opposite to the first case. Like in this situation, if someone have problem of reading the book and letters are not clear, so that is the problem of long sightedness, right?
Yes.
So in long sightedness your image will form beyond retina, right? Or after retina.
Yeah.
So that's why it is known as the long sightedness. If you again consider your eye as a convex lens, so when light rays are coming from the lens, and they will converge at a single point. So basically this point will be beyond your retina, right? You can see a retina is before the focus point, so that's why you are not able to see the near objects, right? So this is the problem with long sightedness. And now you know that what we need to do, we need to use an other convex lens, because eye lens is already a convex, but we need to use another convex lens. So we have to use another convex lens, and that convex lens help you to focus the light rays. Because they will help you to focus the light before coming into the eye, and that will help you to quickly focus the light on retina. So this point will be your retina point. So now your focal point and retina both are on a single line, single point. Okay. So this is the concept for the long sightedness.
Oh, yeah, I think I understand them.
Okay. So always remember the long sightedness, short sightedness. Long sightedness means when a image formed at a long distance from retina, or short sightedness mean when image formed at short distance from retina. It means before retina or after retina. So basically in this problem, your image is formed,
Like right after the retina, isn't it?
yes, after or beyond the retina. Basically it's up to you how you memorize these difference. And in this case you observe that it is before retina or in front of retina. So it's up to you how you remember the difference between short sightedness and long sightedness. And further, if we talk about some more explanation, just like the correction and important thing. So we correct this problem with the help of the convex lens. So if we talk about the correction, so we use converging lens to pre-converge light rays. And secondly, the important point in this concept is in long sightedness, light rays converge at long distance from lens. Okay, so this is the concept. Clear? Any confusion?
No, sir.
Okay, so this is the difference, and this will help you to identify the problem and to solve that problem. And further, if we discuss some question related to the light section, because we completed the section of, we started from the waves, right?
Yes, we started from the waves.
Yes. We completed the wave section, then we started the sound. Sound is the short topic. This topic is important factor affecting the sound. Then we started electromagnetic spectrum. In that we discuss about different types of rays like radio, micro, infrared, visible, all these things. This is also short topic. And after that, we started the light chapter. Light chapter is the lengthy one. We discussed law of reflection, then plane mirrors, then refraction, refractive index, total internal reflection, the lenses, concave lens and the convex lens. And we also discussed this thing, the image formation, right? And the finally we discussed today
Yes.
is defects of eye vision, right? So if we consider some question from light section, we already discussed some questions. Question number 5. So in question number 5, they are asking the ray of light from a ray box pass through 3 lenses placed at position 1, 2, and 3. So there are 3 positions marked on the diagram. So what type of lens is used at each position? So you need to identify that what type of lens we are using at position 1, 2, and 3. So what type of lens we are using at position 1? Can you identify?
It looks like convergent.
Okay. So you mentioned that first one is converging.
Where the second one seems to be like,
Hmm.
I think it's also like converging, while position 3 is like diverging. I'm not sure.
Okay. Third one is diverging. Okay.
Yeah.
Okay. So
I'm
in
not sure.
exam, if you want to identify these things, you can simply identify. Just extend the normal light ray. Like if you consider the first position, so if we extend the original line, so that will give you the concept either your light ray is going to move inward or outward. So you know that your light is moving inward, so it means converging, right? So first one is right. And if you consider the second position, so second position is also like this. So it is also moving inside. So it means it is also converging, right? Because converging means to converge at the center. And the last one is, so in last one, you can see they are moving outside. So it means diverging, right? So converging and diverging. Option B. Okay.
Oh, okay, so looks like I was correct the first time.
Yes. So in exam, if you just confuse on this type of question, you may just take a ruler and draw a straight line with the normal ray. So that will give you the idea that light rays actually converge or diverge, right? So in this case, you observe that your light ray is actually converging at initial 2 points and then diverging at the final position, right? So this is the concept.
I see.
Yes, this is related to defect of eye vision. So which law applies to a short-sighted eye viewing a distant object? So you can compare with your points that we discussed. So this is related to short-sightedness. We discussed the short-sightedness over here. So images actually form in front of retina, right? So in front of retina means either option C, either option D. And what type of lens we used in this problem? Diverging lens, right? Like concave lens. Option D. Okay, clear?
Yes, but how is it option D? Can you explain?
Okay, so basically in short-sightedness, this is the diagram of short-sightedness, right? We discussed that
Right.
in short-sightedness, your image actually focus before retina, right? Or you can say that in front of retina. Okay, you can write this one also as before retina or in front of retina, right? So these two things are the same. Before retina means in front of retina. You can see your focus is in front of your retina. Okay. And secondly, we use diverging lens. It means concave lens. So that's why option D. Clear? Any confusion now?
No, sir.
Okay. Because they use different phrase to ask in question. But if you remember the diagram, so you can easily identify the problem. The diagram shows a thin converging lens of focal length f. Where must an object be placed to produce a real image in the position shown? So in question they mention this is your focus point, this is your focus point, and image is actually formed at this point. So they are asking where must an object be placed? So you can see this point is actually 2f, right? Is also 2f. So your image is actually formed at 2f. So where you need to place your object? Because if you remember the image formation, so if you consider the second case, so when object placed at 2f, so your image will also form at 2f, right? So it means that we need to choose option A, because if you place your object at 2f, so definitely you will get your image at 2f on the right hand side. Okay, clear?
Yes, sir.
Any confusion?
No.
So these are some questions related to the light section.